Today I'm going to look at the Sunsynk 12 kVA 3-phase hybrid inverter and try and make some sense of the electrical specifications that appear in the manual. This inverter is actually a combination of three things in one. One, it's an inverter, and that means it converts DC current from the solar panels into 220 volt AC current that you can use in your house. The second thing it's a solar charger, which means it takes current from the panels, and this current is optimized for voltage and amperage to charge the batteries. It uses maximum power point tracking, which is called MPPT, and this is fundamental to the operation of this inverter. So we'll discuss that a little later in detail. Finally, it's a battery charger, which means it takes AC current from the grid or from an outside charger or wherever and converts it to optimized DC current to charge the batteries. So these three functions work together to create a versatile solar power system. Let's have a look at this architecture slide, and you can see that the inverter is the brain of your solar system. It takes energy from the sun via the solar panels, and it can send it as DC to the battery, or it can convert it to AC and send it to your house, or it can receive power from the grid and send it to charge the batteries. It can also get power from a generator, a wind turbine, or almost anything else. You can see at the top here that you can control this inverter from apps on your phone or your computer. Before we can understand the electrical specifications, we need to know what maximum power point tracking is. The 12 kVA unit that we're going to look at has two of these. It consists of an electronic board like the one above and some software, and what it does is it looks at the current coming in from the various strings of panels, and it optimizes the voltage and the amperage, and it actually increases the efficiency by about 30%. The 12 kVA Sunsynk has one MPPT that it has two strings and another MPPT which is one string. So this unit has three strings, and you could, for example, have your north facing on one string, your east on another, and your west on another, and so avoid the infamous problem of shading, which is where if one panel is in the shade, it affects the whole array. Okay, so let's have a look at the technical specifications, and we are going to look at the 12 kVA model, and this first line which says battery type shows that you can use lead acid batteries or lithium ion batteries. Very few people would use lead acid batteries these days. The battery voltage range, so although the battery is a 48 volt battery and that's its optimum voltage, it can operate between 40 and 60 volts DC, and nothing untoward will happen. The maximum charging and discharging current, as you can see, is 240 amps DC. It'll probably never be subjected to this, but if there was a current that large, either going into the battery or out of the battery, it wouldn't be a problem. The three-stage charging curve is common to most modern batteries, and it consists of three stages. The first stage is bulk charging, where there is a constant current and the charger delivers a maximum allowable current to get the battery up to about 90%. The next phase is the absorption phase, which there is a constant high voltage and the current gradually decreases until the battery is at about 98%. The third stage is called the equalization stage, and for a short period there's much higher volume, much higher voltage, to make sure that all the battery cells are equally charged until it gets up to 100%. This keeps the battery healthy and efficient and is common to most modern batteries. The temperature sensor is used to monitor ambient temperature, to manage the internal cooling for safety and efficiency, and the maximum power point is also found using, among other things, the temperature. The charging strategy is the inverter adapts to the battery management system. Every lithium-ion battery has its own internal battery management system where it adapts to the volts and the amps and so on. And the inverter has a look at this data and adapts to it so that the battery is charged efficiently. Okay, so let's have a look at the PV string input data now, which is the photovoltaic current that results from sunlight hitting silicon molecules, and it is the current that you get from your solar panels. So you can see that the maximum DC input power is 15,600 watts. Now this inverter is only rated as a 12,000 watt inverter, but that's actually the output power. The input power is higher than the output power, and this is a safety feature, and you probably would get away with oversizing in this unit, but it's still not a good idea. The photovoltaic input voltage is between 160 volts DC and 800 volts DC. DC stands for direct current. But you can see that the MPPT management range goes from 200 volts to 650. So you wouldn't really like to get it up to 800 because the MPPT couldn't manage that kind of voltage properly. So when you're designing your string, make sure that the voltage in the string adds up to less than 650 volts DC. The startup voltage is the voltage from the panels that it takes to start up the inverter, and it's probably better to have this at least 220 volts to get it going, and that would be 5 40 volt panels or more. So there is a minimum number of panels you can have on a string. The next line, the PV input current, shows you that on the 12 kVA unit, the first MPPT controller can handle 26 amps direct current, and the second MPPT controller can handle 13 amps direct current. The maximum PVISC is the maximum current if there is a short circuit. The SC stands for short circuit. The first MPPT controller can handle 34 amps DC, and the second one can handle 17 amps DC. The next line tells you how many MPPT trackers this unit has, which is 2, and then the number of strings per MPP tracker, the 2 plus 1, means that MPPT number 1 has 2 strings, so you could have 2 sets of in-series panels wired separately, and they would be managed separately, and the second MPPT tracker only has 1 string available. In fact, you can put 14 panels on the first one and 14 on the second, so this unit has a maximum of 28 panels. Okay, so let's have a look at the alternating current output data. And this unit is rated as an output of 12,000 watts. UPS stands for uninterrupted power supply. So it can run at that comfortably for hours. The maximum AC output is 13,200 watts. This just allows for unexpected surges and stuff, but it could run at that, but probably stresses the unit a little bit. The peak power off-grid is 2 times of the rated power for 10 seconds. In other words, the unit could receive 24,000 watts for 10 seconds. Obviously, you'd combine this with some sort of cutout fuse because you don't want to ruin your expensive inverter. So the AC output rated current is 18.2 for the first MPPT controller and 17.4 amps for the second one. The maximum current is 20 and 19.1, and then the maximum three-phased unbalanced output current is 27.3 amps and 26.1 amp respectively for the two MPPT controllers. Three-phase electricity should be balanced and it should be a perfect sine wave, but for various reasons this doesn't always happen, and this inverter can tolerate when three-phase goes out of balance. If there is a short circuit for any reason, the inverter can tolerate 75 amps, and obviously this should be combined with some sort of circuit breaker at 75 amps or slightly above. The maximum continuous AC pass-through, this is the amount of current that can easily pass through the inverter from the grid or a generator or something, and you should plan your electrical system so that this limit of 45 amps is not exceeded. This next line just outlines the tolerances that this inverter has for the various aspects of three-phase electricity. It can use 50 hertz or 60 hertz. 50 is common in Europe and here in South Africa, and 60 hertz is used in the United States. The 3LNPE, this notation refers to the 3L is three-line conductors or phases, the N is the neutral conductor, and the PE is the protective earth ground conductor. And then those voltages are just the various tolerances for the variations of voltage in the three-phase electricity. This is really just telling us that this inverter is compatible in various regions and it's very flexible for the different conditions of electricity supply. So this unit can be used with three-phase electricity, but it can also be used with two-phase or one-phase. Total harmonic distortion, THD, is less than 3% of the nominal power. Or what that's telling us, harmonic distortion is something that occurs in electricity where there's an unbalanced electricity which interferes with efficiency and flexibility. And what it's really telling you is it's less than 3%, so it shouldn't be a problem. DC current injection, a little bit of DC current will get into the AC side, but it will be less than 0.5%, so that also shouldn't be a problem. Let's look at the efficiency numbers. The maximum efficiency of 97.6% means that this is the highest efficiency the inverter can achieve under optimal conditions. Means that 97.6% of the DC power from the solar panels is converted into usable AC power, with only 2.4% lost in the conversion process. The Euro efficiency is a weighted average, 97%, where the inverter is tested under various European weather condition of snow, hail, cold, hot, and so on. And then the MPPT efficiency is how good is this unit at getting to the MPP, the maximum power point, and it's greater than 99% efficient. So this is a very efficient unit. I'm not going to go into all these protection protocols, but it protects against power surges, voltage spikes, lightning strikes, sudden current leakages, wiring up the panels incorrectly, and all that kind of thing. So if you want to look that up, you just take those numbers down and put it into Google, and you'll find out what exactly all of that means. I'm also not going to get involved in all these power company regulations and safety standards, and I'm just going to go over to general data here. The unit can operate between -40 and +60 degrees centigrade, but once you get above 45 degrees, there is some derating of the efficiency. Cooling is intelligent air cooling. In other words, there's a sensor and the cooling system turns on and off on demand. The noise is about 45 decibels. The communication with the battery management system uses this protocol. The net weight of the unit is 38.5 kilograms. That's the actual inverter. The gross weight is the box that it'll arrive at your house in with all the packaging and the accessories. The cabinet size in millimeters, 422 by 702 by 281. Ingress protection 65 is just the protocol that protects the unit from dust and water and so on, and it's a well-known protocol. The installation type, it's a wall-mounted unit, and the warranty is 5 years. When I first looked at this manual, I had no clue what half of these things meant, so I thought there would be other beginners out there that would be in the same situation, so I did some research and made this video. So I hope you enjoyed it, and thank you for watching, and goodbye.